Hey math kids, today we're going to study some probability related to the game of craps, and the reason why we are talking about this game of chance is because the history of probability is deeply rooted in games of chance or gambling. It's actually the first reason why anybody started studying probability and trying to figure out some of the basic probability laws that we still use today. Um, and so this is a game that's kind of been glorified on movies, and it's fairly complicated to understand the rules. And so I'm going to explain the rules as well as some of the probabilities related to different pieces of this game. So you may have been exposed to this game without even realizing it. The first bet on the board that I'm going to talk about is the pass line bet. So if you put your money or your chips or whatever down on this line, this is what it means. So if we do the pass line on our first roll, or on the first roll of whoever's throwing the dice, if you get a 7 or an 11, then you win. If you, on your first roll, you get a 2, 3, or 12, then you lose. This is where the game gets its name. Those three numbers together are called craps. Okay, so we may come back to that. Now, let's say you went through, you rolled your first roll, and let's say you rolled a 5. So 5 isn't one of these 5 numbers, so what happens is we're pushed into second roll, and the game gets reduced to just 2 outcomes that matter. So on your second roll, if you roll a 5, or whatever you got on the first roll, so it depends on what you get, then you win. If you roll a 7, then you lose. And then you just keep doing this. So your third roll would be like this, fourth row, fifth row. So so if you rolled a 5 on your first roll, the game becomes, will you roll a 5 or a 7 first? And that's how you win or lose. Okay, so let's go back to this, and let's pretend, let's just go through that. So let's say I put down 2 chips on the pass line. And then I'm going to come over here. I'm going to roll my dice, and I got a 5. So what the dealer is going to do is they're going to put a token, or it's just like a marker, on the 5, and that way we remember that that's what we're going for. Now we're going to roll again. We got a 3. Now a 3 is not a 5, a 3 is not a 7, so we keep rolling. Rolled, this time we got a 7, so 7 is actually bad, and so I would have lost my 2 chips, and the game is now over. Okay? Let's see, go here. All right, so that's a pass line bet. Now, let's try again. Let's see if we can win with this one. So this time I'm putting down 3 chips, and we roll. It's my first roll, and we rolled an 8. So they put a marker on the 8, maybe. There we go. And we roll again. So now the game just comes down to, are we going to get an 8 or a 7? 8 is good for us, 7 is bad for us. Okay, we got a 9, so we roll again. We got a 7 again, and so we lost. Okay. So that's how it goes. If I would have gotten an 8, then I would have doubled my chips. I had 3 here, so they would have given me 3 more, and I guess I would have been happy. All right. So if nothing else, hopefully this is discouraging you from gambling, because you just saw me lose 2 times in a row. Okay. All right. Now, I want to take a little bit of a break from explaining the rules and just kind of explaining how rolling 2 dice work. Now, because rolling one dice and rolling another dice are two independent events, they don't affect each other, we can actually just multiply the probability of any single outcome by the probability of another single outcome on a dice, and we'll see that there is 1 in 36 ways to get any one outcome on two standard dice. So what that means is if we want to get a 2, a 3, 4, 5, actually, I'm going to, I need more space. Let's see. I'll get rid of this. So if we want to look at all the outcomes, so like rolling a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, here's all the ways that we can do it. So to roll a 2, you can only do a 1 and a 1. To roll a 12, it's a 6 and a 6 on both dice. Now a 3, you can do 1 and a 2 or 2 and a 1. 11, you can do 5 and 6 or 6 and 5. A 4 is going to be 1 and 3, 3 and 1, 2 and 2. 10 is going to be, 6 and 4, 4 and 6, or 5 and 5. So if we just look at number of ways, there's one way to roll a 2, there are 2 ways to roll a 3, and there are 3 ways to roll a 4. If we start on this side, it goes 1, 2, 3 as well. And this pattern is going to continue. So it's going to be 4 here, 4 here, 5 here, 5 here, and then 6 here. So we see that rolling a 7 is the most likely outcome. Okay? And so when we're in that second roll, we are most likely to lose. Okay? Now, Now on the first roll, we have, pretty good options, right? So to roll 7, we have a probability of 6, 6 ways. And then we have 11, which only has 2 ways. So for us to win on that first roll, we have 8 out of 36 possibilities to win. Okay, so we can throw that into a calculator. And so that's like 22%. Okay, so it's still not very likely that you're going to win. It's less than 1 out of 4 that you're going to win. And if you end up losing, you lose all that money. So it's still not really in your favor, but I would argue that your first roll of this bet is more likely than any of your other rolls, okay, to win. So we won't go into all the probabilities right there, but I just want to take a break and talk about that. Okay, now the exact opposite to the pass line bet is the don't pass bar. And so all that does is it's saying you're betting against the person who's rolling, and so just this win changes to a lose. This lose changes to a win. So on the first roll, you want to get craps. You want 2, 3, or 12. On the second roll, you want a 7. You want, so on the second, third, fourth roll, you want them to roll 7, because this becomes a win and this becomes a lose. Okay, once again, this 5 is not always a 5. It's whatever you roll on the first roll. Okay? All right, let's look at another place on the board. So the field is another place that you can bet. And so this is a one-time bet. And so if you roll, you're saying on the very next roll, you're going to roll a 2, 3, 4, 9, 10, 11, 12. So if they roll any of those numbers, then you will win. So let's look at that. So it's 2, 3, 4, 9, 10, 11, 12. Now, so this is the field bet. So if you roll this, um, you just get even money back, unless you get these, and then you get double money back. So even money is like if you bet one, they give you one more, and so you turn that one into two. Now, if you get the two, so if you bet one, then they would give you two back, so you'd turn that one into three. Now, the probability gets a little bit tricky when we kind of weigh it based on the payoff on this one. So I just want to look at it with whether you win or lose, and I'm not going to take into account the 2 and the 12 being worth double. But if we just talk about winning or losing, there's one way to get a 2, there's 2 ways to get a 3, 3 ways to get a 4. 9, there's 4 ways. 10, there's 3 ways. 11, there's 2 ways. And 12, there's 1 way. So if we add all those up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 out of 36. And we divide that. And so that's about 44%. So since even though it looks like there's tons and tons of options and it feels very likely that you'll win, the problem is it's still below 50%, so it's skewed in the favor of the casino. Okay, so it's not super likely, but it could happen. All right. Now we're going to talk about big 6 and 8. Once again, this is a one-time bet. You're saying on the next roll, they will roll a 6 or an 8. And so just 6 or 8. So if we come down to our diagram, 6 has 5 options and 8 has 5 options. So that's a total of 10 out of 36. If we divide those, we get 10 divided by 36, and we get 28%. So less than a third of the time, anything below 50% is pretty bad because it just pays even money again. And so this is actually a worse bet than the field. So the way that this kind of tricks people is when you're playing craps, you'll actually notice that 6 and 8 show up pretty often. And so if you've been playing it for a while, you're like, wow, 6 and 8 shows up a lot. And it's because it's right next to 7, right? These are the 2 most common things that are not a 7. And so you will see them quite a bit, but I think it's like a psychological game. You see the 6 and the 8 a lot, so you're like, okay, I'm going to bet on that because it comes up a lot. You don't really think about the probability of it. You just note it. You just happen to notice that you see a lot of 6 and 8s. And so I think that's why it's on the board. It's because psychologically when you're playing the game, it feels like those numbers come up a lot. And it's because they do, but they don't come up as often as the probabilities suggest. Okay, so we're going to look at some more stuff. We're going to look at, we're going to come over here. I'm going to move this over. Okay, so we're going to look at everything that's right here. These are all one-time bets, just like this big 6 and 8 and the field. And these ones tell you how they pay out. So they don't pay even money. So if you happen to win one of these, they actually pay out pretty well. And so what we want to do is just see how they pay out and see if they're worth it or if any of them are better or whatever. So let's talk about these right here. These together, technically the bottom ones don't fit in this category, but they actually have the same probability. So we're going to talk about them all as one. So they're called hardways. Like I said, technically the bottom ones are not called hardways, but it's a similar way of thinking. So if we look at this, the probability, so it has to be doubles. You have to roll a 3 and a 3. So if you roll any other way of rolling a 6, it doesn't count. It has to be a 3 and a 3. So you're going to put some money down on this and say hardway 6. And if you win, you get 10 to 1. So if you put down 1 chip, they're going to give you 10 chips. So that seems like a really good deal, right? So if you happen to get that, you could even try it a couple times and then you'd still be fine. Now, if you look at it though, it's doubles. So a 3 and a 3, that's only one outcome. And so the probability of this is just going to be 1 in 36. And the probability of this is 1 out of 36. Probability of this is 1 in 36. Probability of this, 1 in 36, 1 in 36, 1 in 36. Now, for this to be a fair bet, you should be paid out 36 to 1. If you were paid out 36 to 1, then you should, over the course of playing it multiple times, you should come out even. Now, these all have the same probability, but they pay off way different. Because this one only pays out 8 to 1. So for that to be a fair bet, it should have a probability of 1/8. But it obviously doesn't. That's far off. 1 out of 36 is way worse than 1 out of 8. 1 out of 10 is what these would need to be a fair bet. And then this one's a little bit closer, right? Because it pays off 30 to 1, but it's still below being a fair bet. So all of these, I think people know that these are hard to get, but they see those payouts and they think, once again, it's a psychological game. I think they bet on the 8 to 1s because they're like, okay, that's a hard bet, but since it pays out 8 to 1, it must not be as hard. They don't really think about the math, and so I think it's, once again, a psychological game. So if you were ever to do a hard way, you should only do these 30 to 1 bets because they're just as likely as these other ones, but they pay out worse. It's kind of weird, right? Now, these ones, we can kind of think of the same way. They pay out, they not pay out, but they're more likely than the other ones. Because this one, because a 3, you can get a 1 and a 2, or a 2 and a 1. And then an 11, you can get a 5 and a 6, and a 6 and a 5. So these are actually 2. Wait, that's a bad color to use. 2 out of 36, which if we reduce that, we're going to get 1 out of 18. And this will be 1 out of 18 as well. And so the payoff, once again, doesn't quite line up. They should be paying you 1 to 18 to make that a fair bet. But everything is skewed in towards the house or towards the casino. Okay, we have just 2 more that we need to talk about, and then we'll end the video. Okay, so we have 7 to 1 is what it pays out, and it's any craps. So remember, craps are 2, 3, and 12. And so if we look back on that sheet, 2, 3, 12, we have a 2, there's only one way. A 3, there's 2 ways. And a 12, there's 1 way. So total, if we add those together, it's 4. So 4 out of 36, if we go to, if we reduce that, so we divide each of them by 4, we get 1 out of 9. And so for this to be fair, they should be paying us 9 to 1. Okay? And the last thing, this is just rolling a 7. So you see a lot of 7s if you play it a lot, so you're like, oh man, that's really likely. And so we look at our thing. There's 6 ways to roll a 7. And so it's going to be 6 out of 36, which is 1/6. So that's still, the best probability for any one thing. But it's 1/6, and so they should be paying us out 6 to 1 for it to be a fair bet. Now, obviously, casinos are a business, and so they want to guarantee that they make money, and this is how they guarantee it, is they make the odds of their games in their favor, but they also try to play a psychology game where they kind of trick you into thinking different things are more likely or less likely, and it's actually pretty clever way to make money. Whether it's ethical or not, that's up to you to decide. But if you have any questions about this, please come to Math Lab. Until then, calculator.